Hi guys. So I'm going to quickly go through this question because I found it really interesting. So this is a vector, this is a further maths FP1 to be exact, question based upon vectors, 3D vectors. And I've boxed this part D specifically because it was an interesting part of a session between me and a student of mine where we solved it in different ways. Now, the solution to this question suggests you to use simple trigonometry. Okay, you have three lines on a right angled triangle. You know one side, and you know the angle subtending that side and the base of the triangle. Find the other side, and it's simply some permutation of the trigonometric identities, SOHCAHTOA, sine, cos, and tan. That's cute. That's cool. But I decided to solve it in a different way, which was potentially longer, but it yielded a lot more information and it cemented a lot more understanding about the way we use vectors. So that's what I really want to go through in this particular video, starting from the very beginning of the question. So reading the question, it says relative to the fixed origin O, the point A has a position vector 8, 13, minus 2. The point B has a position vector 10, 14, minus 4. And the point C has a position vector 9, 9, 6. The line L passes through the points A and B. Find the vector equation for the line L. The first thing that I've done is write out the vectors in a different way. I like to write out my vectors like this because it makes it more legible for me. And just so that we set up the question, we need to understand what it means by line. So back in GCSE and the early years of A-level maths, we played around with the straight line equation, y equals mx plus c. Not only is y equals mx plus c a function, but it is also a set of instructions, okay? By the time you get to year two maths or further maths or university level maths, you should think of expressions and equations as instructions, okay? The y equals mx plus c is an instruction telling me that in order to get a particular solution, y, I have to go in a certain direction, m. I have to take a certain amount of steps in that direction, m. And I start from a point C or some quantity C. It could be a point, it could be a place, whatever it is. I start from a point C and I move in this direction in a certain amount of steps to get to the solution y. If we think of vectors in this form, things will be so much easier for us. So the question says that the line L passes through A and B. Find a vector equation for the line L. The vector equation for any line is always going to be in a form that is similar to y equals mx plus c. Okay, so the first thing we do is that we note down our starting point. The starting points can be any of the points that the line L passes through. So in this case, A or B. Because of convention, sorry about that. Because of convention, A, B, C, D, E, F, G, etc., I'm going to choose my starting point as A. Okay, so I'm going to write here starting position vector equals A. Okay, and that's from the question, that is simply going to be 8, 13, minus 2. My direction is going to be the vector arithmetic expression between A and B. So my direction vector is going to be AB. So I travel from A to B, and that simply is B minus A, which as an expression is going to be 10, 10, 14, 4 minus 8, 13, minus 2. And that's going to give me a direction vector of 2, 1, minus 2. And we have all we need. So L is going to be equal to 8, 13, minus 2 plus lambda. So I write my lambdas backwards, by the way. Plus lambda, where lambda is the amount of steps we should take in a certain direction, and our direction is 2, 1, minus 2. Okay, so that's part A completed. Part B tells us to find the magnitude of CB. So C is some position vector that happens to not lie on the line. But now we are linking a line from B to C, and we are trying to find the length of that line. So that means finding the magnitude of the direction between C and B. Noting that C is 996. Okay. So CB is simply going to be B minus C, and that is going to be 10, 14, 4 minus 996, which gives me a direction vector of 1, 5, minus 10. That's all well and good. Now the magnitude or direction of CB, remember vectors are, well, vector quantities. They have both size and direction. Okay, we found the direction here, but to find the size, i.e. magnitude, it's going to be the Pythagorean expression of this particular vector. So that's going to be 1 squared plus 5 squared plus minus 10 squared, which is the same as 10 squared, all rooted. And if we work that out in our heads, that's going to be 100 plus 25 plus 1. So the size of the line CB is going to be root 126. Okay? Root 126. Now, part C asks us to find the size of the acute angle between the line segment CB and the line L. Okay? So, by the time you get to a question like this, here is where you should really start drawing out what you're doing. Okay? The vector module is a very, very geometric heavy module where you need to just understand the shape of what you're doing, and you need to be able to be good at drawing the situation so that you can work out the lines, the points, the angles, everything. So I'm going to do just that. I always give this advice to my students in physics and maths. Wherever you can, just draw out what you're doing. So the first thing I'm going to do is that I'm going to draw out the line L. Now remember, these aren't exact. They're just meant to illustrate what's going on in a rough fashion. So the line L is going to be something like this. Okay, so that's going to be my line L, and I have a point A and I have a point B that lies on the line. Now I have a point C somewhere. Okay, I don't know exactly where this point is, but it's somewhere. Okay, and I'm just going to say that it's over here. And so far what I've done is that I have drawn a line from C to B, and I have worked out its size. The question asks us to find the angle between the line L and the line CB. Well, that's easy now that we know exactly what we're doing, because all we're really doing in this case is that we are using dot product to find the angle between the direction of L and the direction of CB. Okay, so if we remind ourselves what dot product is, the full expression for dot product is cos theta A dot B, which is the dot product, divided by the magnitude of the first vector multiplied by the magnitude of the secondary vector. Now these two vectors, there in this case there would be directions, okay? And there's a reason why I said directions. because for L, I'm not going to use the entire expression for L. I only care about the direction, because no matter where I start, if I trace out this direction, I'm always going to get a line that eventually passes through 8, 13, minus 2. So I don't need that. And I also don't need the amount of steps. I just need what my line is actually doing, the way my line is behaving. The same thing with CB. I just need to know the way my line is behaving, which is 1, 5, minus 10. And in the line L's case, 2, 1, minus 2. Okay? So my A is going to be 2, 1, minus 2. 2, 1, minus 2. And my B in this case, which is actually the vector C, is going to be 1, 5, minus 10. 1, 5, minus 10. So when we dot product those two, so 2, 1, minus 2, dot product with 1, 5, minus 10, I'm going to get 2 plus 5 plus 20, which gives me an answer of 27. And that 27 is going to go on top here. Now, my magnitude multiplication is simply the magnitude of these two vectors. I already know the magnitude of this vector here. So the magnitude of this vector is going to be 1, 2, 6. And just in my head, I'm going to work out the magnitude of this vector here. And that's going to be root 9, because 4 plus 1 is 9. And then root that, it's going to be root 9, which is 3. So 3 root 125. Sorry, 3 root 126. And that is going to go on the bottom there. So in essence, to find my angle, I'm just going to rearrange that and do the anti-cos. So it's going to be theta inverse cos 27 over 3 root 126. And punching those values into my calculator is going to give me a value of 36.7 degrees as my angle. Now, I wrote 36.7 degrees because the question asks us to find it in in respect to one decimal place. So, you need to round up, okay? So, part D is where it gets really juicy, right? So if we go back to the drawing that I did, so far what I've done is that I found out this angle here. And this angle here is now going to be 36.7 degrees. 36.7 degrees, okay? I don't really know, well, I can find out if I wanted to, but I don't really know the direction between, the distance between A and B. D asks us to find the shortest distance from C to the line L. So I've placed C here. Let's just, for the moment, assume that this isn't the appropriate position of C. What if I put C over there, or over here, or over there, or over there? No matter what I do, the shortest distance from C to the line L is always going to be a straight line that is perpendicular to the line L. It's always going to be a straight line, okay? It's always going to be a straight line. So if I just rub all those out and just draw a straight line from C that is, as best as I can, perpendicular to the line L. And just to reiterate that, I draw my perpendicular symbol there, okay? And this is the distance D that the question wants you to work out. And because the distance between C, or the direction between C and the line L is perpendicular, that makes this angle a 90-degree angle. And that is going to be just, this is just going to be a trigonometric problem, okay? So I've got my angle, I've got my hypotenuse, I'm trying to find my opposite to the angle. So the trigonometric identity that I would be using to find this out is going to be sine theta equals opposite over hypotenuse. So that's going to be d over root 126. Rearranging to find d, that's going to be root 126 multiplied by sine theta, where sine theta is 36.7 is d, and d is, if I just punch that very quickly into my calculator, that is going to give me an answer of 6.7 or 6.71. Okay, so that's the answer which we should be getting if we just do simple trigonometry. But that's boring. I'm not going to do that. I'm not going to do simple trigonometry. Instead, I'm going to fully understand and flesh out what it means to work with vector equations. Okay, I'm going to draw a point here, a point X. And I'm going to say that point X lies on the line. Point X lies on the line such that I should be able to start at A, go some steps along the direction of L, and eventually reach X. It also happens that point X to C, so the direction between X and C, that vector must be perpendicular to the direction of the line L. Okay? So I'm going to write here that point X lies on L. Okay? Such that XC is perpendicular to L. Okay? Point X lies on the line L such that the direction XC has to be perpendicular to L. Okay? So the first thing I'm going to do is that I am going to express my X in terms of L. So if we recall what L was 8, 13, 2 plus lambda 2, 1 minus 2. Okay, so X therefore has to be 8 plus 2 lambda. Remember, we don't know what lambda is. We just know that we will take a certain amount of steps, lambda, along the line L in order to get to X. Okay, so far, that is our point X. Okay, if that is our point X, then our direction CX must be equal to 8 plus 2 lambda, 13 plus lambda, minus 2 minus 2 lambda. Take away the position vector, which was 996. The point C is 996. And that is going to give us a direction of minus 1 plus 2 lambda, 4 plus lambda, minus 8 minus 2 lambda. Okay? Now, remember what I said here, such that the direction XC is perpendicular to L. The direction of L, as we recall, is 2, 1 minus 2. And the direction of XC, as we've just expressed here, is minus 1 plus 2 lambda, 4 plus lambda, minus 8 minus 2 lambda. It so happens that when two lines are perpendicular to each other, the dot product must add up to 0, because the angle between those two lines is 90 degrees, and cos 90 is 0. So that's why the dot product equals 0. So we have an expression here where we can work out what lambda is, and then once we've worked out what lambda is, we can substitute that back into any one of these to find out their respective vectors. So Once I find out what lambda is, I can plug it back into here to find out what the position vector x is, or I can plug it back into here to find out what the direction of cx is, and then use Pythagoras to find out the magnitude of cx, which ends up being my value d here. Okay, so let's do dot product, and we get an expression 2 minus 1 plus 2 lambda plus 4 plus lambda, also in brackets, minus 2, 8 minus 2 lambda equals 0. That's going to give me minus 2 plus 4 lambda plus 4 plus lambda plus 16 plus 4 lambda equals 0. I absorb like terms. So that's going to be 9 lambda equals minus 18. So lambda must equal to minus 2. Okay. So I'm going to rewrite this x position vector and this vector cx with the lambda equals minus 2. So if lambda equals minus 2, then my position vector is going to be 4, 11, 2. And if lambda equals minus 2, my cx vector is going to equal to minus 5, 2, minus 4. And we need to find the magnitude of this vector cx because that equals to d. Yeah. So let's find our our magnitude of cx. Okay. So cx equals minus 5, 2, minus 4. Therefore, the magnitude of cx is going to equal to minus 5 squared plus 2 squared plus minus 4 squared, all rooted, which is the same thing as 25 plus 4 plus 16, all rooted, which when I punch that into my calculator, that gives me the same value, 6.7. I hope you learned something. I'm not really well. We could. I could if I wanted to, but I don't think there's a point because since we know part E says that the point X lies on L, given that CX is perpendicular to L, we already know this. I've just told you. And find the area of the triangle CXB. Well, let me just if that distance there is 6.7, and from X to B, I've actually already worked it out in my, just very quickly before I made a video. So the distance between X and B is actually 9 when I do the Pythagorean, when I find the magnitude of the vector XB. So XB actually equals 9. The area of the triangle is just half base times height. Half AB sine theta, but the theta is 90 degrees, so sine theta equals 1. And that gives me an answer of 30.15. But regardless, I hope you learned something of how to really understand what's going on when you are using vectors and you are playing around with the expressions. If in an exam, you don't have enough time, yes, of course, use the use the trigonometric identity and just punch numbers in. That's cool. But if you know that you're struggling to understand, it's always better to just push yourself and go through the motions of understanding exactly what it means to have a vector equation. What is this vector equation telling you, and how can you use it? Okay. If you have any questions, just post in the comments below, and I'll answer them when I can.